Good morning.
Hello.
Evening.
All right. So I saw that there were that Stephen Kitt put stuff on agenda for today, but I haven't checked it since earlier this morning.
Yeah, I also snuck something on there.
Okay.
Yeah.
I don't see it. Oh, there we go. Okay, well, we'll give it just a few moments. How's everybody doing today?
He did.
Great. How about you, Paul?
I'm doing okay. Wish this was a short week, but you take what you can get.
Yeah.
All right, well, we'll just give it one till the clock strikes 12:32, and then we can go ahead and get started. All right, the clock strikes 12:32. Stephen, why don't you go ahead? Got cluster set IPs on the agenda.
Yep, thanks. Yeah, so this is so since Laura's been driving things to hopefully a conclusion in the near future, I thought this was perhaps a sort of speak up now or hold your peace sort of thing about cluster set IPs. So it basically this comes up sort of because of the spec shouldn't drive implementation, well, shouldn't specify implementation details side of things, and I'm trying to figure out exactly how much of cluster set IP is implementation detail and how much isn't, with the background, unsurprisingly, that in Submariner we don't currently support cluster set IPs. And so the big reason behind that is that we don't touch kube proxy, and so we don't have virtual IPs, and there would be other ways of dealing with it. So it's not necessarily, we're not driving to actually remove cluster set IPs because we can implement them in different ways. But I just wanted to make sure that the spec is correctly bounded, sort of thing. And so the questions that arose when I was looking into this are, well, how essential are they? That's the first one. And so I guess they are already essential because of the stance that's taken in Kubernetes in general, that services should have virtual IPs, because DNS, well, relying on DNS to move things around isn't actually all that reliable because of TTLs and applications that do a lookup once and then keep the result forever. So I don't know if anybody else has any comments on this particular angle.
Yeah, I think that's basically it. We had this conversation a bunch back in the early days, and that characteristic of services and cluster IPs has just been really valuable time and time again, because so many client libraries, applications, whatever, don't actually do what they're supposed to do with DNS.
Yeah.
and with the MCS APIs, what we really wanted to do, right, is make it possible to just consume multi-cluster services like you consume um, services within a cluster.
Standard services. Yeah.
Yeah, and
Yeah.
so they need to have the same accommodations.
Mhm.
That was
Yeah.
kind of the thinking.
Yeah, it definitely makes sense. Yeah, that's sort of the impression I've gained more and more working with the MCS API. The real value add isn't so much all the sort of underlying technology that it assumes, or rather that sort of falls out from it, but it's just being able to consume services without caring about where they are, because that's what
Right.
users end up seeing. Okay, and so the sort of what saves us in Sabrina, at least, from having too much complexity and having to touch kube proxy, even if we wanted to support cluster set IP, is the provision in the spec that's already there that cluster set IPs can be cluster specific. And so I was just curious if there was, and I don't think there is really, but would it make sense to be able to distinguish cluster set IPs that are the same across a cluster set and cluster set IPs that aren't? And I'm thinking really that consumers shouldn't care about this unless they end up sending IP addresses to other clusters, but that would be really bad. And if we allow that, then we're just asking for trouble.
Right. Yeah, I don't think a consumer should have to care at all. I mean, we kind of took the stance that consuming a service, I mean, all service consumers are assumed to be within a cluster, right? And then consuming a service should rely only on information local to the consumer cluster. So, I don't really see why the consumer would have to care.
Yeah, I don't think so either. It just
and that gives us more flexibility in implementations, as you're saying.
Definitely. Yep. Yeah, and so moving on to actual implementations, I was intrigued by the mention in the Kubernetes service docs that kube proxy. Yes, kube proxy's responsibility to implement virtual IPs for services, and I guess the answer is probably no, but I was wondering then if it would make sense to sort of extend that kube proxy responsibility to also cover service imports. But that would be pretty bad, I think, in terms of allowing different implementations of the MCS API, because effectively you're just moving the interface.
Right. Yeah, I think. Or sorry.
Yeah, go ahead.
Sure. Like one. I don't happen to remember if this was encoded as like a goal, but one thing that has run through our conversations about, potential implementation pathway has been that like ideally we would not have to touch kube proxy, because the moment you do that, now you have an entanglement between version of kube proxy and functionality that you get, right? And future rollout maintenance headaches around like which versions of kube proxy a customer may be using or a user may be using. So like I said, not sure if we recorded it as a goal, but there's certainly a tangible but not easily estimatable cost to requiring changes in kube proxy.
Yeah. Yeah, which sort of leads to really why the conclusion that I'd written down in the agenda already. Ultimately, we want to avoid requiring any functionality in kube proxy. That should be an implementation detail.
We should also, I feel obligated whenever the discussion comes up about should we do something in kube proxy, to point out that kube proxy is a completely replaceable component, right? It is an implementation of a somewhat undefined interface. And so when we say, should we put it in kube proxy, what we're really saying is, should we make it somebody else's problem by jamming the logic in there and saying, well, if you run Cilium, Cilium gets to implement this. And if you run Entria, well, Entria gets to implement this, right?
Yeah. Yeah, and Laura actually mentions, and I'd forgotten that. She mentions in the chat that we did drop explicit kube proxy support of service imports as a beta blocker for MCS API in discussion a couple of weeks ago, although the KEP isn't updated yet, so that settles that.
Right, and if you want kubeproxy to handle it for you, there's an easy way to do that. We've done that in the demo, and there's a few implementations doing it already, where you just create basically a dummy service that represents the multi-cluster service with the right endpoints, and then kubeproxy handles it, but without having to update kubeproxy. And that also generally
deals with the virtual
should
IP
work for everyone else who implements the single cluster service API.
Yeah. Yeah, and it means we don't need to actually know whether it's kubeproxy or some other replacement for it that's taking care of it. It's just create a service and that's it. Yep. And so the final point, so I'm not actually familiar with all the details behind this, but so I was hoping that Vishal from the project would be able to connect, but apparently not. But anyway, he was wondering about aggregated service imports. And if there isn't a risk there that they end up requiring a common cluster set IP across all clusters.
Yeah, I wouldn't think they do, right? Because the cluster set IP, I mean, assuming it's something like kubeproxy that's implementing it, cluster set IP is only for consumers in each cluster, right? So if you have consumers in multiple clusters, like as long as that cluster set IP can route to backends in multiple clusters, I don't think we have any requirements around a common IP. I think that is strictly up to the implementer.
All right. Yeah, I'm just looking through the KEP again, and I don't see anything. Okay, yeah.
I see, Gabe, you've got a hand raised.
Yeah, I was just going to go back to the topic of the cluster set IP itself. I can't remember from the spec. Does the controller need to pick an IP? Like, is it responsible for IPAM?
Yes.
Okay.
But like in the example implementation we've got, one solution is create that dummy service and let kubeproxy do it for you. Like there's a bunch of different answers, but yes.
I see. So then the same thing that's creating the service import is first creating the dummy service, getting the cluster IP out of it, and sticking it back into the service import.
That would be one answer, but I would still kind of put that in the bucket of the implementation is responsible for providing an IP.
Yeah, I'm just one. Okay, right.
I don't think we've said anything that would prevent users from specifying IPs too in an implementation. Well, except that that creates all kinds of headaches, I think, that we've seen in other areas, and really the implementation needs to own service import, and that's where the IP is created. So by whatever mechanism it gets there, implementation can decide.
Yeah, I'm just like noticing that there's like a slight inconsistency with regular service API. Like regular service, like I can create a cluster IP service without specifying an IP, and the implementation underneath that API for service goes and fills it in for me. Whereas here, I can't go create a service import. Like that doesn't make any sense for me to create a service import without a cluster IP, like without the IP specified.
I think the distinction here is a human creates a service usually, and a human does not create the service import. They create the service export.
Yeah.
Right.
Service import is
not parallel.
Right.
Yeah, one might even consider that service import is an in-spec implementation detail. It's something that's completely it should be hidden from administrators and end users. Really, well, I mean, they never need to interact with it.
Yeah, that's what I'm trying to figure out whether there's some value in actually allowing for divergence, like a thing that writes service imports in a completely independent system that implements them. Like, would we see that emerging? And if so, would we want to have semantics around I can create one without an IP specified?
Yeah, I don't think I'm not seeing creating the service import without an IP specified. But definitely, like you create a service export without specifying an IP, and then the import gets created with one.
Sure.
I guess I feel like we've broken the service concept into two pieces, and like the service spec is now kind of the set of services and service exports that make up that service, and the service status is that is the import. Like it's owned by the implementation. It's updated. The user shouldn't be controlling it directly, just consuming it.
Right, but then like why specify it as an API at all?
Well, because consuming it's valuable, right? Like I want to see the multi-cluster services in my cluster. I want to understand
I see.
what they
Okay.
are. Yeah.
I want to provide DNS for them.
Right. Yeah.
That's okay. Yes. Okay, thanks.
Yeah, it's always DNS. Right, well, yeah, that covers it from my perspective, I think. Thanks for the discussion. And really, it's sort of, yeah, it just all boils back down to the first point, really, since we want the same guarantees for cluster services as we have for cluster set services as we have for in-cluster services, then we need cluster set IPs, and everything falls out from that.
Sorry, I don't think I actually understand that reasoning. Can someone try to just like restate it for my thicker head? Like why do we need cluster set IPs again?
So yeah, so the going back to the in-cluster services. So without considering MCS API, there's this in the service description itself. There's this requirement that services are backed by virtual IPs that remain constant, and the value there is that basically round-robin DNS can't be relied upon to work.
I get that within a cluster, but I'm trying to figure out. Yeah.
But then, so the same, and so really, an exported services, or rather an imported service, but basically a cross-cluster service should be consumable in the same way an in-cluster service is, and so that ends up meaning that they should also be backed by an IP address that doesn't change from the consumer's perspective, which means we end up in the same sort of, well, with the cluster boundaries applied, we need a virtual IP address that is the same for all clients in the same cluster for a given cross-cluster service. And that doesn't change.
Okay. I think I'm following now. Thanks.
So sort of retro continuity, if you go back to the beginning of Kubernetes and you say service is an API that describes a virtual IP that covers the set of pods that make it up. And there's no implementation. Ignore kubeproxy. There's just the API, right? You can choose to implement that with actual load balancers and just dynamically programming them, or you could implement them in some other way. Kubeproxy is a reference implementation that happened to stick of a way to do that, right? In fact, the first kubeproxy was in fact a proxy. It was a user space thing that would copy bytes from one socket onto another socket, right? And we want with multi-cluster services to hold that API boundary a little bit more rigorously and say, the API boundary is service import defines an IP address. We don't care or prescribe where that IP address comes from or what it means, but it is an IP address that represents the set of pods across clusters that make up a multi-cluster service. Now, we know the implementation, that the reference implementation has been built on top of kubeproxy, but put your fingers in your ears and pretend that didn't exist, right? It could be a real load balancer if you wanted it to be. Or it could be BGP, or it could be something else, right? Does that help at all?
Yeah, thank you.
Okay, did I lose audio or like what happened?
I hear you.
I hear you.
Okay, everything
I
just
hear you.
got really quiet. It's like one of those classic moments at a party where everything gets quiet, and then you're shouting. I won't tell the rest of the joke. Anyway, all right, Laura, you ready to screen share?
Yes, I'm sharing my screen now. Can you see it? I've taken control.
Oh,
Yes.
all right.
Okay, great. Okay, I wanted to give a little update about the CRD bootstrapping project. that's kind of happening under the waves, question mark. But a little bit of background is that cluster ID, which we describe in this CAP cluster ID for cluster set identification, and which is also referred to as cluster property because that's the CRD name. We need it to be installed before the MCS API controller, which is depending on it, can do stuff, particularly program DNS records. Maybe Lucy's haiku is also relevant here. We also, as a SIG, believe that the CRD would be useful outside of just clusters who implement the MCS controller and should be available on cluster startup. So this next slide, I think, is pretty recognizable for a lot of people who've been following the cluster property CRD, but just FYI, this is what the actual CRD itself is. So a little bit more background too is a while ago, we went to SIG architecture to kind of talk about this, about whether it even should be a CRD or if we should implement it in KK if we believe that it should be widely available and available on cluster startup. And the takeaway from that meeting was that the existence of a CRD bootstrapping mechanism that was independent of the MCS controller, which was being discussed with SIG architecture at the time, is sufficient cause to not put cluster property in KK. So that kind of was like the operating principle we were moving forward with. So I just want to give an update on how that's going from what I've seen thus far. So some other people may also be more or less up to date on this. There are basically 2 or 3 major conversations about it, as I can tell. This POC, which is on GitHub by the group that's working on this, that uses a post-startup hook to install CRDs from a manifest. Then there was an announcement on SIG architecture's mailing list, and it got CC'd to our mailing list too, so people may have seen, and there was some conversation out of that. And then it also got brought up at SIG API Machinery last week. So that meeting is kind of what I'm reporting on a little bit now. From my perspective, there's sort of 2 pieces that this has been kind of split into. What makes the API server reject or otherwise make it feel like you can't access this cluster yet until this thing is installed? So that's kind of like the deny traffic part of it. And then what actually installs the CRD itself, which then conceivably opens up the deny rule, and now you actually can come in. So it kind of got split into those 2 things as the conversation progressed. The current status is that on that deny side, there's some talk about adding another webhook, since apparently you can only make one, in Kube API server's authorization chain, so that you could block traffic until a or all target CRDs is/are installed. So that's the deny side, and it sounds like that's definitely going to progress. But then what installs, that has been a little bit more controversial from what I've seen. It could be by some platform admin, programmatically, or by a human. It could be more inside the open source side by an arbitrary bootstrapping binary that's run with the add-on manager, or by a new controller via controller manager. And just to kind of skip down about connecting this red asterisk with this red asterisk, this installer part seems pretty controversial as of that last meeting. Most of the consensus is being built around denying traffic. There is sort of a separate project to write out all of the pros and cons about all of these. There's some technical details which I didn't 100% follow, but that make using controller manager or add-on manager not great for all situations. By situations, there's a distinction between cluster startup and cluster upgrade that these processes have different properties from SIG architecture's perspective that make them complicated to address. So hopefully that made some sense. When I said it in my head, it made more sense than I feel like when I said it out loud. But this is the status right now. For me personally, I think I'm going to follow up with the folks who are writing up this pros cons list about these 3 points. My perspective is we as SIG Multicluster do care about where this install step happens. And as it happening in the open source side is what we want. But let me know if I'm super off base there. And that's the info.
Awesome. I mean,
Thanks.
To me, it sounds like there is basically a plan for bootstrapping CRDs. Like I think it sounds like we still haven't figured out necessarily what that is, but there's a fair amount of confidence that there will be one. Does that sound correct?
Well, I would say the end of the SIG API machinery meeting, it was kind of rushed at the end, so that's why I want to follow up a little bit too. But these three options, like by a platform admin, by the add-on manager, by the controller manager, the add-on manager and controller manager seem attractive to our SIG from my perspective, because this would be like in open source, but they were on thin ice, I guess, by the end of the meeting. But again, it was kind of rushed. So I guess I want to get some more perspective on how strongly we feel that the actual install process, whatever, the thing that actually is like, I'm installing the CRD right now, I think that's important to us. And if so, I kind of want to circle back with those people and push on that and be like, I think that we do need this in open source for our purposes.
Laura, is there a doc that discusses, like I didn't get to go to whatever meeting this was, so is there a doc that discusses these things in detail?
It doesn't exist yet. That's part of what also happened in the very last like 30 seconds of the SIG API machinery meeting was like, we should make a doc, right? So I'm gonna run after those people and see that that happens, or if I can help too, because I have some of the context as well from following along. So I think that will make it a lot more clear to everybody.
I mean, the truth is this is a hard problem, and like I started a doc on this. I'm trying to find it now, like 18 months ago, and the accumulation of issues that needed to be tackled pushed it from, like out of the realm of reality for me to tackle myself at the time. And I'm hoping that I'm hopeful that we solve it. We have to figure out how to tackle this. There has to come a point at some point in time where we decide this is taking too long and we don't really want to delay this valuable functionality, and we make an argument for, well, sorry, it doesn't seem reasonable to wait for the boat, so let's do the other thing. But we've done this in the past and we're still doing it, and at some point we have to stop doing it, right? And I don't mean to make SIG Multicluster the sacrificial lamb on this one. I'm also holding SIGNet's feet to the fire on the same topic. So
spicy.
So I guess my thoughts on here are, yes, I agree. Like, we can't wait forever for this to happen. At the same time, we want to make progress with cluster property because we have some immediate use cases. We think it would be really great if this was bootstrapped in the cluster, because we can come up with lots of theoretical ideas for how you would use a cluster ID that was always present, but we don't have any tangible ones that we're working on right now that actually need that. All of our use cases would be fine with a CRD that is installed at some point after the cluster is created. So I'm trying to think, if we say this is taking too long, which way should we actually go? Is it worth pushing in tree for reasons that we don't really understand, or do we just go with the CRD because we know that actually does solve our needs?
So from my perspective, two things. One, I think before we do any action because we feel that we have been waiting too long, we should try to quantify how long we think would be too much longer to wait. In the interim, before that pathway for CRD initialization exists, I think we can like change the language to be bound by like the CRD has to exist before X or Y thing can happen. And when the mechanism we're waiting for is available, we can just say that like now that can coincide with cluster creation essentially.
Right. Okay, I think most of our language actually fits that already. So
Yeah, I think so
that's
too,
actually
but I
reasonable.
can double check.
I wonder if anybody else has thoughts on that.
Josh also asked, do we have a CAP for a desired path? We could link that to the SIG Arch CAP and use as pretext for lobbying for faster action. We have some information in this CAP, like a section on to CRD or not to CRD, which I think we could stick up in there. Our needs are like we're a direct influence on speeding up this project in SIG architecture, like in the SIG API machinery. We were called out directly, so we are definitely a known use case, but we can put, the paper to the paper for sure on that.
One dimension that I think should not be like forgotten is that, like Laura just said, we did apply some activation energy to have this recognized as a priority. So I think it would be great for us to be like one of the first consumers of that and like be there to provide feedback on it because we asked for it to be prioritized. So that's sort of another thing in my head around bias toward like, let's call it a CRD. We'll know that CRD like bootstrapping will materialize and improve in the future. And it will be great for us to provide feedback around it. Like those new things are like really, really important and valuable to give feedback on. Because, the newer it is, the fewer people are going to use it.
Cool. I will give further updates as I have them if this was valuable. And if anybody else has any comments or concerns, let me know. Otherwise, I will cede my time.
Awesome.
Okay. I'm sorry, I'm going to take a stab at pronouncing your name. Is it Anil?
Yeah, that's right.
All right. Excellent. Well, you have the floor. Go ahead. MCS with multi-network setup.
Okay, hope you all can see my screen.
Looks good.
Crystal clear.
Cool. Just to introduce myself, so my name is Anil. The background is basically, I think right now, so I work for Intuit. We also have some more representation from the company. We are working on we already have a multi-network setup with Kubernetes clusters spread on different networks. And today we are using Istio and service mesh and on top of that, some additional controller, which is pretty similar to MCS controller that kind of orchestrates and puts all these services together with a load balancer. And that's what this diagram is. And I think the reason for presenting here and getting this across and the doc across is basically bringing in this use case as a valid use case, and also overlaying this on top of what constructs we already have in Kubernetes, including the MCS spec, and seeing where the gaps are to get this model going. So having said that, let me zoom this a little bit. Okay. Hope you guys can see this better. So basically the scenario we have is like every Kubernetes cluster, it either belongs to, like it belongs to a region, and then it also is in a separate network. And then we have, so if you see in this particular example, so there is a workload A that's trying to consume workload B that's spread across, like it has instances running in different clusters in different networks. The view that workload A would see, like for example, it's calling b.dns. I just made that up. It could be anything pretty much. Would be, it would have a couple of endpoints. It would point to b.svc.local, which is what the conversation was in the beginning of this group discussion, where it's a cluster local IPs. And then it would also have a load balancer 3.com, which is basically the ingress into cluster 3, where the other instances of workload B are running. It could be the same region, it could be the different region, but in this case, it happens that it's in a different region. Now, if you see, there's also a concept of weighting here, like the weights that are added to the endpoints, because you might have a different distribution of the number of instances that is running, or for other reasons, like for example, the canary across clusters, you want to distribute the traffic differently across these endpoints. So that's a view the workload A would have for workload B as it's consuming the b.dns. And the way the DNS is set up is, again, it uses the underlying proxies Envoy. So it's using all the constructs that Envoy has, and then all that the controller does, the controller I'm talking about, which is very similar to the MCS controller, is it renders this view as it observes all these clusters across different networks. It understands that they are on different networks, and it renders this configuration that the workload A can now consume, where it can simply rely on calling b.dns, and it's totally transparent, and rest of the magic is handled by the proxy based on the weights and the locality that's defined for each of these endpoints. And it also aggregates all of, like, you can think of it as very similar to service imports that we are trying to do with MCS, where the service imports basically represent the service in every cluster. So this is very similar, except for like, yeah, you have endpoints directly. And then the gateway we are talking about here is a SNI router and pass through, where it can still understand the name that it's trying, like the service is trying to call, and it can route appropriately to the respective workload based on what the host name is or the DNS is. Any questions so far?
This is super interesting. One question that comes to mind is whether you think it's possible that you could turn your existing implementation into an implementation of MCS, like with some mutations. Can it implement MCS?
Yeah, I think we think so. And then like we see there are like some constructs that are already there. That's the thing I'm going to talk about next. But then there are like some gaps that would need to be filled before I think that implementation can happen. So that's basically the second set of the second part of the discussion. So if you look at, I mean, this is like based on the MCS spec. So if you look at the very same problem, so workload A is going to consume the service import B. And if you look at the service import B, like the way you define it, like it's backed by endpoint slices. Each endpoint slice represents a service behind it. Like it could be the cluster local, or it could be a remote instance of that service B, right? And endpoint slice already supports the FQDN or the IPv4, like, so you can render it differently. So the implementation that we have can basically do this, which is it can render the IPs if it's within the cluster. It can render the IPs of the load balancer or the FQDN, which is a the DNS for the load balancer of the target service, or sorry, the target cluster. Now, the problem comes when there are two problems. One is identifying the network for the cluster. So as part of the MCS spec, there isn't that yet defined yet. So we need to see if these clusters belong to the same network, which means the IPs are routable across clusters, so that you don't have to use a you don't have to use a load balancer. You can directly connect to the workloads in another cluster. Or if you can identify the network, again, going back on like what Laura presented, we could use the same machinery API, or like there is a cluster similar to cluster ID. You could also have a network, and by default, it could be the same when clusters are connected, and then you can change that net. Like you can basically bootstrap the cluster with the network. And if every cluster has a different network, then it's the MCS controller can do what I have pictured here, which is you create these endpoint slices, and then you point that endpoint slice at the Kubernetes gateway. Now there is this Kubernetes gateway API that's pretty new, and I think it solves a use case that's basically meant for exposing services. And it can also be extended to support the cluster set services that can be exposed from the gateway. And the very similar model that I explained, I think it should all work. Like one of the few open questions we have is the endpoint slices today, like they do not have weights. The problem here is like whatever sits behind this gateway on the right hand side, you don't know like how many instances of that workload are running, or like the number of pods. So it becomes difficult for like the workload A that's consuming this workload B to load balance in a right manner, right? Because it all you have is a load balancer IPs, and that doesn't give you enough information to distribute the load evenly. That is possible only if we can have weights on the endpoint slices. So I think that seems to be like one of the important, one of the gaps. Now the other thing, like the routes and gateways, as they are defined for the gateway API, I think they should be able to. I mean, they should be again extended to support the cluster set local hosts. But I think I don't see like a major concern with that. But yeah, that's still something that's required before this model can be implemented.
Why do you say that the spec needs to be extended? Like, I think I'm tracking what you're saying, but that would be an implementation of the MCS controller to go create those things, right?
That's true. Yeah. Yep. That's correct. I don't think the spec needs to be modified. I think it's more on like the implementation side. I don't think there is anything implemented or restricted just to the cluster set local.
Can I ask one question before we go much further? You mentioned Istio at the beginning of this. This feels a lot like what Istio does with their Istio gateways. Am I missing a distinction?
It is a very similar model, except for like Istio has multiple implementations of like there is Istio where every cluster has its own control plane, and it's not aware of the other network. It's running on a single cluster, and that's the model we use because like for us, we have hundreds of clusters. We cannot have like a single control plane look at all the clusters or like all the endpoints. Now, that being said, there is also another model of Istio where you can run, like if you have a handful of clusters, you can have a single control plane. And in that case, this is exactly what happens. Like it watches all these clusters and it basically uses the gateways. Yes.
But they also, I'm not a super familiar with Istio, but they also have a way of representing I think external endpoints. So they could, in this case, if you had two different control planes, you could represent the other one as an external endpoint in the same service, right?
Exactly. That construct is called service entry. You can bring in like a service, and then that is exactly what I was referring to here in this this box right here, the b.dns. That's basically a service entry that's translated by Istio into Envoy configuration, like where the proxy understands.
Got you.
The load. Yeah.
How do you have more slides, or do you have more you want to talk to? Because there's a few people in the chat who are saying we've got questions. I know I've got a few. I'm sure other people have a few, but I don't want to jump all over you.
Yeah, I think I think that's pretty much what I have. And then the network identification, I think I already talked about it. We could use something very similar to cluster ID to represent the network for the cluster for the MCS controller to consume. So yeah. With that, yeah, I mean, the whole point of having this is to have discussion. So yeah, all questions are welcome. And yeah.
Just one quick thing too. I think one of the things we were looking for feedback on too in this was how much of this we wanted to pull. So right now, this is a very kind of Istio. This would be a very Istio-ish specific implementation of MCS. I think part of the question was, do we want to bring some of this into more general concepts where it could be applicable besides just like an Istio implementation of MCS. So I think it's one of the parts we were kind of looking to get some feedback on this as well.
Do you intend for this to be HTTP only, or do you use it like Istio tries to do a full encapsulation of TCP traffic also?
I think it's for both, I would say, yeah, not just HTTP.
We primarily use it for HTTP and HTTP2 traffic right now, but I don't necessarily limit that.
The reason I ask is the FQDN thing sort of set my hackles up. Like obviously a plain old TCP client is never going to be able to resolve a FQDN properly through IP tables, right? Like there's an extra step that needs to happen there. Versus a proxy, which could do dynamic FQDN resolution, like if the proxy is doing full encapsulation, right?
Yeah, yeah. I get
encapsulation.
Yeah, today we definitely use the proxy for the full encapsulation to be able to resolve it. I don't think we'd be able to make it work without the proxy there.
If it's, I think, yeah, Tim's point is like if it's HTTP, then I think that's possible. If it's TCP, then it's not possible for the proxy.
Yeah, right. If I'm an arbitrary client and I want the full set of endpoints, and you have one endpoint slice that's filled with IPs and one endpoint slice that has an FQDN in it, I'm not sure that if I'm a smart client and I'm consuming it directly like a proxy, cool. If I'm trying to consume it through transparent like IPVS or BPF or something else, then something has to resolve that.
Yeah, but maybe lack of my understanding, but like, didn't we say that all these service imports will get a virtual IP and the clients are supposed to connect to it? And
yes, but if I'm going to resolve an FQDN into so the virtual IP is a front end to a set of well, let me back up. In the default implementation, like kubeproxy, that virtual IP is a front end to a bunch of back end IPs. If we want to put a host name in there, something has to actively resolve that name to an IP or set of IPs, put that into the set, and then repeat that process over time, right? SIGNet is talking about how to do FQDN-based policies, so it's not like it's off the table, but it wasn't really considered for services. It was only considered for policy space. But wouldn't be against it in this regard. But having it be in the proxy makes a lot more sense.
okay.
I think Gabe was next with the hands.
I actually think that Gary had his hand up first.
Oh, sure. That didn't matter to me. Yeah, I guess, being new to the group, but having played around with, multi-cluster service, I guess what struck me a little bit about this proposal, I mean, cool, don't get me wrong, was though, and maybe I'm on the same point as Tim was, it seems to mix a couple of paradigms, right? Because like, it seems to try to mix and match the traditional before multi-cluster services way of exposing services across clusters, right? With like an external load balancer, L7 or whatever. with potentially service like imports and exports, right? Like, because you wouldn't have this notion of like, you almost end up with this load balancer to a load. You could end up with like a load balancer in front of with a back end of multiple load balancers, which is why you ended up with like the weights on like endpoint slices. So it just seems like you could end up with this sort of very layered proxy load balancer architecture. So moving things up more to layer 4, layer 7, rather than trying to deal with things at kind of the layer, say 4, layer 2, 3, 4, 2 and 3 networking layer, which I thought, multi-cluster services was more designed to do. So I guess that would be my kind of take, but maybe I missed something in the proposal in what you were saying.
So if I can respond real quick, and I don't mean to jump the queue, so I'll be fast. From a SIGNet point of view, I don't actually object to the multiple layers here. I think it should be a valid model. I mean, my enthusiasm for perfect solutions has been tempered by talking with a lot of customers, and this seems like the sort of thing that could actually work in practice, in much broader practice. And so I'm not inherently against it. I do think it is building a higher level construct on top of a lower level construct, but I'm not sure that that's a bad thing. I just think it's different, and we need to think about it.
Yeah, I think to me it all sounds reasonable if the consumer experience can stay the same. I think that's really kind of the goal with the MCS API, is really focusing on the consumers, and making it as easy as possible. But there are some questions there, and obviously this introduces some complication. And then I think the big question that I'm getting here from Anil is, should this be like something that MCS actually tackles, or is this some like Istio add-on kind of thing?
Is there, other than weights, is there something that this needs from the spec? Like if we added weights, this could be a completely transparent implementation of MCS, right?
I think so, yeah.
And I mean, my position on Istio has always been, if Istio can implement MCS, then cool. It's a valid implementation of the MCS semantic, right?
Yeah, that's actually the plan.
And I guess weights, right? If you think about, sorry if I cut, but weights could work, right? In the case you have weights here based on the fact that you had like 3 instances of it, right? But weight could be from the fact of like in one cluster, for example, somebody's got like this thing backed by 6 CPUs, 6 vCPUs, and in one cluster they've got it backed by like 1, right? On a vertical scaling perspective, right? So weight still might be applicable even in the more standard case, right?
Yes, it has been proposed in SIGNet several times. We haven't engaged on it yet because it's a pretty slippery thing to grab a hold of. Remote clusters with multiple endpoints is much more obviously necessary than different sized pods, because size is not always proportional to CPU, or capacity is not always proportional to CPU or memory.
Right.
Correct.
Like that seems like an excellent foot gun. Very useful in certain situations, but also incredibly likely to do incorrectly or unnecessarily.
And yet pretty much a requirement to get sort of next generation load balancing capabilities, right? Like modern load balancers need some sort of feedback about capacity and fullness that isn't related necessarily to requests per second. It isn't necessarily related to connections per second. It's related to the actual state of the observed universe on those backends. And that's just something that SIGNet doesn't have an answer to yet, but it is definitely on the radar.
So one on this topic, and I'm also sorry for kind of jumping the gun, but on this topic, I brought up at the Istio meetup last week the idea that maybe this can be an Istio extension on endpoint slice. Like if Istio can implement weights for multi-cluster services based on endpoint slices, then we could maybe start there, like to the consumer and the exporter of a multi-cluster service. The API is, the contract is completely honored, and there's just a little extra magic happening behind the scenes. To me, that seems like a reasonable place to start.
I think the issue we had with that was that we kind of wanted Istio to kind of be able to layer the functionality on top, right? Like, so we wanted to be able to work with an existing MCS controller as well as be the MCS controller. And if we start relying on Istio extensions, then that doesn't really work out so well.
What does extension mean? Like endpoint slice doesn't really have an extensible model because it's driven by a central controller.
With a weight, and basically these are would be like managed by endpoint slices where keyproxy ignores them and Istio takes responsibility. It's like one answer. We need to figure out what that actually looks like.
Yeah, annotations for this are kind of awful because a slice could have as many as 1,000 endpoints, right?
Well, instead what you would do is, so here's the thing. I don't think that quite is the scaling concern, right? Because it wouldn't be per endpoint. It would be per remote network where you need weights. And so you could just have, this would be a little ugly, but you could, if you had 3 remote networks, you could have 3 endpoint slices, each with 1 endpoint and annotated with a weight. I don't think it's so bad. This would not scale nicely to 1,000 remote networks per service. But that starts, I think.
Well, I mean, I guess that just devolves into an endpoint slice scalability problem, right? And like, honestly, endpoint slice, if you have 1,000 slices of 1 endpoint each, like if it doesn't scale to that, I'd be disappointed.
Is probably fine. Yeah. Cool. Gabe?
At that point, it's not even necessarily an Istio extension. It's just an extension. It's just, it's extra decoration.
Yeah, and I was actually thinking that if Istio started here, maybe we'd upstream it once there's a reference and we can kind of figure out the words.
Okay, I'll jump in here. Yeah, I had a comment on a question. The comment is the network identification part seems to me like there might be a case where a cluster is on more than one network, so I'd be reluctant to rely on cluster property to like try to carry that information because you can't have more than one of a given name. The question is sort of like I think this is maybe rhetorical, but I wanted to kind of like hear your answers. Like, what do you see as the benefit of telling your users to use the MCS APIs to get this functionality, as opposed to just having them use Istio directly?
I think it's a native capability. I think there is like a lot of extra like constructs that are used, and like also the controller, like it's not like it becomes like those one-off things where it fits only to the model that we have, but we think that it fits like with the broader community, and it like most of the other companies also use the same thing. So and running through basically the same problems. So I think having it in like at the Kubernetes level would benefit the community and also be more generic than what we have.
We've also had a lot of customers that that really just kind of want to gradually opt in to mesh, and we don't really have a good mechanism for that in Istio. We just kind of assume that everything is everywhere by default, and then we have a little bit of hackery where you can say define certain services as cluster local. So if you're in a cluster, you'll only go to endpoints in that cluster. But we don't have anything beyond that. So we probably eventually want to have like a more sophisticated policy where we say, you can more generally define what endpoints you can access from where, to kind of meet a wide variety of use cases. But this seems, at least as an interim, a pretty good stepping stone toward a better policy API as well.
We are almost out of time. I've got a hard stop at least. I had the last hand, so that's perfect. There was one other idea I want to throw out there. How common is it really to have a single service that with endpoints that span multiple networks? Certainly multi-network, multi-cluster makes a lot of sense. You've got clusters in different networks. They need to consume services from each other. But how often do you really have like service foo that has endpoints in networks A and B, instead of like in multiple clusters, potentially all within one network. Because if we could just add a constraint saying that, at least for now, a service must be backed entirely by endpoints in a single network. Your consumers can be anywhere. You can have as many services as you want across in different networks, but each service is wholly contained within a network. Then this gets really easy. Then for remote network services, the cluster set IP is just a gateway to that other network, and the endpoints are all on that network. And we get rid of that other layer, and the MCS controller just does a little magic to figure out who or when a cluster set IP should be local, or when it should be a gateway. But consumers and exporters get a much, nothing changes for them, and overall this seems to be a lot simpler.
So you're kind of sounds like you're referring to subsetting using service in a sense.
No,
Right.
I'm thinking you just set the requirement that like a service must be exported from only one network. Like you just say, we don't support a service with endpoints in multiple networks.
From Istio's standpoint, I'm pretty sure that wouldn't, fly for a lot of customers, I'm imagining.
I guess
definitely
it would be interesting. What are the use cases though?
No, I know
yeah,
just
that's
for
a fair question.
Yeah, no, just for us, like we run a lot of our services will run in like multiple regions. So one service will run in like, US West and East, for example. And one of those regions, the services themselves will either run like active, depending on whether their state management can do it, or that'll be like their failover region.
Okay.
So then depending on where the client is, it would look, that's where we kind of get into, depending, like, for example, you might have two services that are running, in the same cluster, but one of them fails over to the other region, for example. We have different scenarios like that. So it's not, if we represent it as one cluster, as one endpoint, then we would have to like kind of use another layer on top of this to be able to manage that endpoint with where to route the traffic to. I don't know if that makes sense or not.
Yeah, no, it does.
I'll add to that. A lot of installations still use a per cluster overlay model. And so getting into and out of a cluster still requires some sort of gateway.
Okay, well, that answers that. So I guess we need to solve this waiting thing. Cool. We are just a bit over time, and I want to be respectful of everybody's time here. But thanks everyone this week, Stephen, Anil, Laura, for great conversations. This is excellent. And it'd be great to keep this going next week too, if there's more thoughts around this. I think we've talked for a long time about needing to figure out multi-network for MCS, and the answer has been we'll figure it out in the future, and it sounds like we are approaching the future. All right. Thanks everyone. Happy Tuesday.
Tuesday. Bye-bye.